Self-driving cars were supposed to change everything. No more drunk driving, no more distracted texting behind the wheel, no more human error, the cause of over 90% of traffic accidents. At least that's the promise. Companies like Tesla, Waymo, General Motors through its Cruise division, and Ford Motor Company have invested billions of dollars in autonomous technology. Tech leaders once predicted fully autonomous cars by 2020. It's now 2026. So here's the real question. Are self-driving cars actually safe? Or are we beta testing unfinished technology on public roads? Today, we break down the data, the hype, the crashes, the lawsuits, and the future, because the answer is more complicated than you think. And yes, parts of this video were generated with artificial intelligence for research and scripting purposes. Some information may contain minor inaccuracies, so always verify critical data independently. Let's begin. Part 1. What self-driving actually means. Before asking if they're safe, we need to clarify something important. Most cars on the road today are not fully self-driving. There are 6 levels of automation defined by SAE. Level 0, no automation. Level 1, driver assistance. Level 2, partial automation. Level 3, conditional automation. Level 4, high automation. Level 5, full automation. Most self-driving cars in America are level 2. For example, Tesla Autopilot and full self-driving are still legally level 2 systems. That means the human driver must remain attentive, hands on wheel, eyes on road, ready to take control at any moment. Despite the name full self-driving, it is not fully autonomous, and that misunderstanding has already caused serious consequences. Part 2. The safety argument for self-driving cars. Let's start with the strongest argument supporters make. Human drivers are terrible. In the United States alone, roughly 40,000 people die every year in traffic crashes. According to the NHTSA, human error contributes to the overwhelming majority of accidents. Drunk driving, speeding, distraction, fatigue, aggressive behavior. A machine doesn't get drunk. A machine doesn't text. A machine doesn't fall asleep. Companies like Waymo claim their vehicles have driven millions of autonomous miles with fewer injury crashes than human drivers in similar environments. AI systems react in milliseconds. They have 360-degree awareness through radar, cameras, and LiDAR. They don't have blind spots in the traditional sense. Statistically, in controlled environments, autonomous vehicles often show lower crash rates per mile compared to average human drivers. On paper, the technology looks safer, but paper doesn't drive on real roads. Part 3. The crashes that shook public trust. Now we talk about the incidents. In 2018, an autonomous test vehicle operated by Uber struck and killed a pedestrian in Arizona. It was the first fatal crash involving a fully autonomous test vehicle. Investigations revealed safety driver inattention and system limitations. Then came multiple high-profile crashes involving Tesla vehicles using autopilot. Some involved drivers who relied too heavily on the system. Others involved the system failing to detect stopped emergency vehicles. The problem? Level 2 systems create a psychological gray zone. Drivers feel safe enough to relax, but the car still expects full human supervision. This is called automation complacency, and it may be one of the biggest risks of all. Part 4. The data war. Are they actually safer? Here's where things get complicated. Autonomous vehicle companies often publish internal safety data. Regulators publish crash reports. But raw numbers can be misleading. Why? Because autonomous miles are often driven in well-mapped cities, good weather conditions, and lower speed environments. Human drivers operate everywhere. Rural roads, snowstorms, construction zones, high-speed highways. So comparing average human crash rates to highly controlled AV environments isn't always fair. However, in cities like Phoenix and San Francisco, fully driverless Waymo vehicles have reportedly logged millions of miles with relatively low injury rates. Still, critics argue we don't yet have enough nationwide data. We're early in the adoption curve. Statistically speaking, small datasets can distort perceived safety. Part 5. Edge cases, the real challenge. Self-driving cars struggle most with edge cases. An edge case is an unusual situation. A pedestrian dressed in dark clothing at night, a temporary construction sign placed incorrectly, a police officer directing traffic in an unexpected way, a mattress flying off a truck. Humans use intuition. AI uses pattern recognition. And while AI can process massive data, it struggles with unpredictable chaos. Weather is another major factor. Heavy rain can interfere with cameras. Snow can block sensors. Fog reduces LiDAR effectiveness. Humans also struggle in these conditions, but humans improvise. AI follows training data. That difference matters. Part 6. Legal responsibility. Who is liable? If a self-driving car crashes, who is responsible? The driver, the manufacturer, the software developer. In Level 2 systems like Tesla, responsibility typically remains with the human driver. But in Level 4 systems like fully driverless operations by Waymo, liability becomes more complex. Some states have begun adapting laws, others lag behind technology. The legal framework is still evolving, and that uncertainty affects public trust. Part 7. The psychological factor. Here's something rarely discussed. Humans fear losing control. Even if statistically safer, people may reject a system that removes their agency. Airplanes are safer than cars, yet many people fear flying more than driving. Self-driving cars challenge something deeply emotional: control over our own survival. Trust in algorithms is not just technical, it's psychological. Part 8. Are media reports skewed? Every time a self-driving car crashes, it makes headlines. When a human driver crashes, it barely makes local news. This creates perception bias. We judge autonomous vehicles more harshly because they're new. But here's the counterpoint. We expect machines to be better than humans. If they're not dramatically safer, why accept them? That's the standard the public applies. Part 9. The economic pressure. There's another factor: money. Autonomous tech represents a trillion-dollar industry. Ride-hailing without drivers means no driver salaries. Logistics without drivers means 24/7 operations. Companies are racing toward deployment. But critics warn financial pressure can push technology to market faster than it's ready. History shows that premature deployment in safety-critical systems can backfire. The automotive industry has faced this before. Part 10. The future. What happens next? Most experts agree, full Level 5 autonomy everywhere is still years away, but limited geo-fenced autonomy is expanding. Cities with mapped environments are testing fully driverless taxis. Sensor technology is improving. AI models are getting better at rare event prediction. The question is not if autonomy will improve. The question is whether society is willing to accept transitional risk. Because during any technological revolution, there's a gray period: not fully human, not fully machine, not perfectly safe, just evolving. Conclusion. So, are they safe? The honest answer is here. Self-driving cars are not perfectly safe, but neither are humans. In controlled environments, advanced autonomous systems may already match or slightly exceed average human safety levels. However, they struggle with edge cases. They depend on clear conditions. They create overconfidence in drivers, and legal frameworks are still catching up. Right now, the safest system may be human plus machine working together, not fully autonomous, not fully manual, but assisted. The road to zero traffic deaths is long. Autonomous vehicles might be part of the solution, but they are not a magic fix. Not yet. And maybe the real question isn't, are self-driving cars safe? Maybe it's, are we ready for them?